Hi guys, so Jason has asked me to go through a past paper question, which is question 12 from the 2020 paper. I will put up the question on the screen in a second so you can follow along, and I'm just going to read it out. So it says the diagram shows a curve with equation y is equal to 4x to the half minus 2. 4x is greater or equal to 0. And a straight line with equation y is equal to 3 minus x. The curve crosses the x-axis at A, 4, 0, and crosses the straight line at B and C. Question A. Find, by calculation, the x-coordinates of B and C. So if we have a look at B and C, we can see that both the graphs are intercepting. So we're going to use simultaneous equations there. So basically I'm going to set the one equation equal to the other equation. So we get 4x to the half minus 2x, which is the equation of the one graph, and I'm going to set that equal to 3 minus x. And what this is going to do, it's going to help me find out what the x value is where they are equal. Okay, I'm just going to take everything to the one side. Take this to the side, becomes a plus, so we get here minus x minus 3 equals 0. So what we've got here now is I've got, this is to the power of 1. I've got one power is half the other one. So this is going back to the beginning of the year where we use substitution. So I'm just going to say let k be equal to the smaller of the two. So this is the smaller one. And then I square both sides. So if I square this, I get k squared. And if I square this side here, I'll just get x. So that is what I'm going to substitute now, is I'm going to back substitute for this and for this. Okay, so we get 4x to the half. Half is the k, so we get 4k. Minus x to the 1, which is this one here, is k squared minus 3 equals 0. I'm just going to rearrange, put the highest powers of k first, divide through by negative, and then we can factorize. So we get k is equal to 3 or k is equal to 1. But we haven't solved for what the question is asking. We need to find the x coordinate. So I need to back substitute my k, which is this. So we get x to the half is equal to 3. X to the half is equal to 1. Square both sides to get the x, and we get 9. Square both sides, and we get 1. So having a look at the drawing, we can see that B must have this x coordinate and C must have that x coordinate there. All right, question B, show that B is the stationary point on the curve. So we need to show that B is the stationary point. In order to do that, I know for any stationary point, my gradient is 0. So if we take the equation of which B is on, which is 4x to the half minus 2x, and I differentiate this and I set it equal to 0. So in other words, we take the derivative, set that equal to 0. In other words, we're finding out where is the gradient equal to 0. So let's differentiate this. So that's going to give us 2x to the minus a half minus 2 equals 0. Just divide through by the 2. And what we can do now is we can solve for this. This is basically going to be 1 over x to the half minus 1 equals 0. Multiply through by x to the half, so we get 1 minus x to the half is equal to 0. take this one to this side, and we can get x to the half is equal to 1. Square both sides, and we get x is equal to 1. And the question was, show that B is the stationary point. So I already said over here that B has an x coordinate of 1. And we just proved that the stationary point, or the x value for the stationary point, is 1. So we've shown that B is the stationary point of this curve over here. Okay. Now going on to question C. It says, find the area of the shaded region. All right, so I'm just going to redraw this over here just so that I can explain what's happening. And it's just a very rough sketch of it, guys, so we can just basically see what's going on. And we've got a straight line that goes through like that. Okay, so yes, my drawing looks a little bit weird, but all we want to do is just find out that area over there. We know that this point over here is a 40. We know what this point over here, this x value over here, is 9. We work that out over here. And we know that the equation of the straight line is y is equal to 3 minus x. And the equation of this graph here is y is equal to 4x to the half minus 2x. Okay, and again, we want to find out this shaded region over here. So remember how we do this? We take the one up at the top minus the one at the bottom. In other words, the integration up at the top minus the integration at the bottom. So if we have a look here, the integration up at the top is going to be, if I just looking at the shaded region, here's my straight line at the bottom. So the top graph would be this one over here. So this is top, this one is bottom. Okay. So if we want to find the area under the curve for this one over here, I'm going to be taking it from this point up to this point here. Okay. So that's for the straight line. So what I need to do is I need to find out what is the value of this x value over here. So that's the straight line. And what we do there is we just make y 0. So that's 3 minus x. So we get that x is equal to 3. So now I know what this x value is. And let's find out the area from the bottom for the shaded region. So I'm going to find out the area of the bottom. So it's going to be the integral from this x value up to this x value here. So it's going to be going from 3 up to 9 of 3 minus x dx. Integrate this and we get 3x minus a half x squared. And we are taking the bounds from 3 to 9. Okay, so I'm just going to do this one time on the calculator, and I'll show you here on the calculator how I do it. So we're going to take the upper bound, so it's going to be 3 times 9 minus a half 9 squared. Subtract the bottom bound, which is going to give us 3 times 3 minus a half times 3 squared, and we get minus 18. Okay, don't worry about the negative just yet. It'll come out just, the answer will come out properly just now. So now I'm going to look up at the top. Okay, so the top graph here is this one over here. Okay, however, what we're doing is we are not taking the area from this point over here for that graph there. What we're doing is we need to get rid of this little area over here. So we are actually running from this point to this point for the top bit, because all we need to do is get rid of that little bit of an area there. So I'm going to be taking the integral from, now this point over here, they told us was 4. So it's going from 4 up to 9 of 4x to the half minus 2x dx. Okay, so if I integrate this, I get x to the 3 over 2. Divide the 4 by 3 over 2, and we get 8 over 3 minus x to the power of 2. Divide that by 2, and we just get 1. Okay, and we are evaluating that from 4 to 9. Again, just put this on the calculator, and I'll show you. So we are getting 8 over 3, 9 to the power of 3 over 2, minus 9 squared, and we are subtracting 8 over 3, this is going to be 4 to the power of 3 over 2, minus 4 squared. And we get minus 43 over 3 is the area for the top. So the total area, or the shaded region there, so shaded region is going to be equal to top minus the bottom. Okay, so our top, we've got an area of minus 43 over 3 minus, and the bottom is minus 18. Okay, so I basically take this answer and I add 18 to it, and we get 11 over 3 units squared. And that's the solution, guys. Thank you.